Hello, this is Patrick at OneCNCWest, and welcome to the very first video in our brand new series called The Whole 9 Yards. Now, these videos are intended to guide you through the complete process of programming a part using OneCNC CADCAM. We're going to take a look at how to analyze dimensions to figure out the most efficient way to create geometry. We'll create the geometry. I'll demonstrate how to move the datum, the X0, Y0, Z0, apply the toolpath, simulate the toolpath, create a job sheet, and then ultimately create a CNC program. Now, this type of video is more focused on providing details than providing a quick video. In fact, this video is just about 37 minutes long. So if you'd like an in-depth overview of how to create a complete program within OneCNC, stick around, take a look, and please make sure to leave any comments or suggestions below. All right, so let's get started. Now, the first thing you're going to notice is that in the layer browser, there is a layer called print, and we can turn that layer on and off. And within that layer, you're going to find the dimensions. We're going to be using this layer to make sure that our geometry creation is right on track, as well as ensuring that the geometry we create is absolutely dead on accurate to these dimensions. All right, so let's take a look at the geometry. We have an outside boundary and we have two holes. These holes go all the way through, and then there's a 50 thousandths chamfer on each side. So let's take a look at this and figure out the best way to create this geometry. I think for this, it would be easiest to create these two outside circles and then create the tangent line and then the fillet, then we'll create the holes. So if we take a look at these two outside circles, they have a radius of 1 inch, which means we can use a diameter of 2 inches. So let's start to create those circles, and also remember that the circles have a distance of 3 inches. I'm going to turn the print layer off. Let's head over to the command manager and select our arc tool set. Now within the arc tool set, the very first command that's already highlighted is the circle command, and that's exactly what we want. For diameter, I'm going to highlight that, hit the delete key on the keyboard, and then type in 2 for 2 inches. And let's use coordinate input for this. This first circle is going to be located at X0, Y0, Z0, so I can simply just click the OK button. Once I click OK, OneCNC has created that circle. Now, if we want to create the next circle, we're going to place that at X 3 inches. That looks good. And again, we'll click OK. And when we're finished, we can hit the escape key on the keyboard. Very good. And if we toggle our print layer on and off, we can see that our geometry is right on track. All right, now let's create the line that's tangent. So to do that, we're going to head back over to the command manager. And for this, we want to use our line tool set. You'll notice over here on the left, there's a group of icons. Now, when you're first learning OneCNC, you might not know what these icons mean quite yet. So what you could do is click on the Home button. The Home button will show you the icons as well as a nice little description that's to the right. Well, we want to select our line tool set, so let's left click that. And the second option is called Line Tangent. Let's use that. I'm going to left click. I'm going to take my cursor, left click the circle. You'll notice we have the little tangent icon. Move my cursor over to the circle on the right, left click, and when we're finished, we can right hand mouse click. Also note within OneCNC, when you right hand mouse click, that's telling OneCNC that you have finished an operation or you're done with a command. All right, now let's create this fillet between both of these circles. This has a radius of 1 inch, 500 thousandths. To do that, we're going to head back over to the command manager, and I know the fillet tool is located inside of our arc tool set. So I'm going to left click the arc icon, and if we look, sure enough, there's the fillet option. All right, now within the fillet option, the fillet radius is already set to 1 inch, 500 thousandths. But notice how I have disabled trimming selected. That's because I don't want this command to automatically trim the geometry. So I've activated this. Let's take our cursor, we're going to left click, move over to the next circle, left click, and now when we move our mouse, we're going to have different solutions provided by OneCNC. That's the solution I want, so I'm going to left click, and when I'm done, once again, we'll hit the right hand mouse button. Very good. All right, now let's trim this. I'm going to be using the scissor command. Now your trim tools are going to be located in the tool set called Trim Brake. Let's left click Trim Brake and you'll notice there's an option called Scissor. Now scissor trim works like this. You simply take your cursor and select the portion of the geometry you want to get rid of. So I'm going to left click, and left click. When we're finished, we can right hand mouse click. Let's check our geometry against the print now. Let's head back over to the layer browser and we're going to turn the print layer on and off, and I'm thinking all this looks great. Now let's create the two circular pockets. These have a radius of 750 thousandths, and they're actually located at the center of those larger circles or arcs we created a little earlier. So let's remember these have a radius of 750 thousandths. We're going to turn our print layer off, back over into the command manager. We're going to select our arc tool set, circles already selected, and for the diameter, that's going to be 1 inch 500 thousandths. Now, of course, you can type that in, but let's say that we didn't, or we couldn't figure out that the radius 750 thousandths times 2 equals 1 inch 500 thousandths. You can type in formulas within OneCNC anytime you have numeric input. So I could type in 0.75 times 2, there's the formula, and then if I hit the equal sign on the keyboard, OneCNC will calculate that and place the result within the parameter. So 1 inch 500 thousandths is perfect. We don't need to use coordinate input. We can take our cursor. As soon as we see the little diamond, that means we're at the arc center. So we can left click. We'll do the same to the other side. Wait till we see the diamond, left click, and when we're finished, we can right hand mouse click. Now, when creating and using wireframe geometry for manufacture, you do not need to create the chamfer. If you want to, you can create the chamfer when, let's say, you're using a solid model, because that's going to be a better representation of the part. And I'm going to demonstrate that next. But I do want to drive home the point that if you're using wireframe geometry for applying toolpath, you do not need to create the chamfer. All right, all you need to do is create the hole. And that's exactly what we've done here. Having said all that, let's go ahead and create a solid model. Now, because the solid model is not mandatory for toolpath, I'm going to be placing it on a separate layer. So let's head back over to the layer browser in the lower right-hand corner, and let's create a brand new layer specifically for our brand new solid model. Let's right-hand mouse click, select Add a Layer. There's the new layer. It's called Layer 1. Now, if we want to rename this, we can double-click, and we can type in whatever we'd like. Let's just type in Solid Model. I think that looks great, so we'll click OK. And with that layer highlighted, now when we create the solid model, it'll be confined to that layer. Let's head over to the command manager. I'm going to click the home button just to show you the selection or tool set you need to select, and that is the extrude tool set. It's right here. This is going to be available within Mill Expert and Mill Professional. So let's left click the extrude command, and we're going to be using extrude curves. Now, it's important to note that the extrude curves command requires closed boundaries. And that's exactly what we have here. We have a closed boundary on the outside, and really each one of these circles represents a closed boundary as well. So all we need to do is select the boundaries. We can select them anywhere we'd like, just with a left click, a left click, a left click, and then when we're finished, we can right-hand mouse click. Now, to create the solid model, you can move your cursor up or down, and if you look over on the left, within the parameters dialog, there's a height option. You can definitely type in a height. For example, we could type in minus 250 thousandths or positive 375 thousandths. In this example, I'm going to grid point snap. I'm just going to take my cursor, I'm going to pull it down, and as I'm pulling the cursor down, I'm going to wait till the height says minus 250 thousandths, and then I'll left-hand mouse click, and when we're finished, we can right-click. Very good. So there's our solid model. And now, just so that this represents the part, we're going to create the chamfers. All right. So let's head over to the command manager. And from there, we're going to select our model tools. Now, model tools is this option right here. And within model tools, there's an option called fillet. When you select fillet, you're going to find out quickly that the fillet command also gives you the ability to create a chamfer. So I have chamfer selected. and the chamfer distance is going to be 50 thousandths. Let's click OK to that. Take our cursor, and all we need to do is just left click the edge where we'd like to create the fillet. I'm going to left click, and then when we're finished, right hand mouse click. And there we go. There is our solid model, and it's placed on a separate layer called solid, so we can turn all the other layers off, and there's our brand new layer. So we can turn that layer on and off just by clicking on the little eye there. Very good. I'm going to turn our solid model off. Let's turn our wireframe geometry layer back on, and now let's start to apply toolpath. But you know what? One more thing before we do that. Why don't we do a little housekeeping, and let's rename this layer 2 to something that makes a little bit more sense. So to rename the layer, we're going to double click, and then up here I'm going to type in, how about wireframe? We'll click OK to that, and there we go. That's a lot more organized. So now we have a print layer, we have a solid model layer, and we have a wireframe layer. And remember, the solid model is not required for toolpath. All right, this looks great. Why don't we start to apply our toolpath now? The next step really should be to create some stock. So why don't we do that? Though we don't need to create a separate layer, why don't we do this just for good housekeeping? So again, within the layer browser, we're going to right click, select add a layer, and that layer is going to be called layer 1. So I'm going to highlight that. And then we're going to head over to the command manager. And from there, we're going to use our line tools, and we're going to select rectangle. All right, I'm going to choose a color that's a little brighter for this. Let's use that color there. And of course, you can use coordinate input for this, but I'm just going to grid point snap. In fact, I'm going to snap right about there. I'm going to drag the rectangle down and to the right. And when we get right about there, I think that looks pretty good. Let's left-hand mouse click. All right, so there is our stock geometry. Let's rename our layer, so we're going to double click, and we're going to call this stock. Now, there are some instances within OneCNC when you need to use uppercase letters for your stock layer, but we'll talk about that in a later video. But for now, we'll just call this stock. We'll click OK, and there we go. We have a stock layer that we can turn on and off. Now, another thing to address is right now, the datum is right at the center of this circle, the X0, Y0, Z0. Now, if you were to mount this part within a vise, you probably would want the datum in the upper left-hand corner. There's two things you can do here. You can select all the geometry and move it, but there's a simpler way to accomplish this. What we're going to do is we're going to move the datum from here to that upper left corner, and the tool we're going to use is the Work Shift tool. Take your cursor over to the right, right-click on the toolpath group, and select Work Shift. From here, within this menu, this is how we tell OneCNC how we want to locate the new datum. I'm going to use Endpoint. Now I can take my cursor, left-click that corner, and now that is the new X0, Y0, Z0. So any toolpath we generate right now is going to be referenced off of that location. And what's really nice is that when you create geometry, the origin is still here, but for manufacture, the origin's right there, upper left corner of the stock. All right, so for the very first toolpath, I think we ought to use a roughing operation. So let's head over to the command manager. We're going to be using our stock toolpaths. Now, stock toolpaths are for 2.5 axis machining, and these require wireframe geometry. So this is exactly what we want to use. We're going to be using our pocketing operation, so let's select that. OneCNC wants us now to select our boundaries. We're going to select the stock, select our outside shape. I'm just left clicking, and when we're done, we're going to right-hand mouse click. Now, the very first dialog box that appears is where we select a tool. And we can either select a tool from the tool library, or we can manually create one. In this first example, let's just manually create a tool. We're going to say this is in turret position number 1. Our RPM is set at 3,750. Our feed rate I have set at 35 inches a minute. Now, you have two feed rates. This first feed rate is your XY feed rate, and this feed rate is your Z feed rate. By default, when you type in a feed rate for X and Y, OneCNC will take that value and divide it by 2 and give you an automatic feed rate for your plunge rate. Plunge rate is the feed rate that gets applied anytime the tool feeds along the Z axis. Now, of course, you can overwrite that. You can type in whatever you want. And in a later video, I'll show you how you can change the formula so when you type in a feed rate for X and Y, it'll calculate whatever you'd like for the plunge feed rate. I'm going to leave that at 35 inches a minute. Let's come down to the holder. For holder, I'm going to be using a 1/2 inch side lock. I think that looks good. And by the way, you can create new holders. You can select from any of these predefined holders if you'd like. Let's click OK to that. That looks good. For tool type, we're going to be using an end mill. I want to show you something though. If I click here, notice how some of the tool types are grayed out. That doesn't mean you can't use them. It's just that the tools that are not grayed out, these are the tools that OneCNC suggests that you use. But you definitely could select any other type of tool that you want. For this, we're just going to be using an end mill. The overall length, that's how far the tool sticks out of the holder. I've got 1.5 inches. The flute length I have set at 1 inch 250 thousandths. And this is all dynamic, by the way. If I type in a different value, notice how it updates over here on the left. We want to put that back to 1 inch 500 thousandths. For the flute length, we've got 1 inch 250 thousandths. That's also dynamic. I'm going to leave that alone. And our diameter is 5/8, 625 thousandths. Very good. So let's click next on that. All right, so here's where we define our clearances and depths of cut. Now, the rapid Z plane, I want you to think of that as your Z safety plane. That's the Z level the tool is going to wrap it up to as it positions itself from one location to another. So think of that as your safety Z plane. I'm using 1/2 inch here. I think that looks good, and that's represented by this red grid. This is also very dynamic. Think of the gray rectangular plane as your Z0, and the Z plane is your rapid Z plane. So if I were to type in a different value, let's say 1 inch, you'll see that Z plane hop up there. And by the way, if you're using a solid model, OneCNC will show the solid model here instead of that gray rectangular shape. I'm going to put that back to 1/2 inch. That looks good. The plunge clearance, that's represented by these little black corners. This is the Z level that the tool is going to start feeding down. 50 thousandths is fine. Material Z top is 0. The final Z depth, I have it minus 250 thousandths. That's represented by the blue plane there. So if you type in a different value like minus 0.5, that blue plane is going to hop down there. But let's put that back to minus 250 thousandths. That looks great, so let's click next on that. Now there's different machining styles you can use. I'm going to be using high-speed open for this. We're going to leave all these parameters set to default and just click next. Now for the approach style, you have 3 different strategies: plunge, ramp helix, and ramp zigzag. I'm going to use plunge because since we're using the high-speed open strategy, the plunge is going to happen outside of the stock. So plunge is perfect for that. Let's click next. All right. Now for the auto step over, this is a percentage of the tool diameter, and this defines the step over for each pass along the XY axis. By default, this is a percentage of the tool diameter, and right now it's set to 75%. But also notice underneath here, OneCNC provides the decimal equivalent. And by the way, if you don't want to use a percentage of the tool diameter, you can uncheck this and you can type in a decimal value, for example, 400 thousandths. But I'm going to recheck this, and let's put that back to 75% of the tool diameter. Rough depths is if we want to take multiple depths of cut. I don't want to do this for this part, so I'm going to leave that unchecked. Finish leave on sides, I'm going to leave that at 20 thousandths. Leave on bottom, I'm going to leave that set to 0. Going to use the default tolerance of 2/10, and let's click finished and let OneCNC generate the tool path. And there we go. There's our first machining operation. And if we look within the NC Manager, you're going to notice that our machining operation is listed here as mill pocketing. Now, if you want to, you can rename this just by double-clicking. And then within the NC Processing dialog box, down here where it says description, you can type in whatever you'd like. I'm going to backspace this out. And I'm simply just going to type in rough. Just like that. And then we'll click OK, and that instantly updates the name of the machining operation. Now, if we want to, at this point, we could simulate our toolpath. In fact, why don't we do that? We're going to take our cursor, right-hand mouse click on the toolpath group, select Simulate Rest, And we want to choose this option called Pick a Boundary because we want to select this rectangular shape we created earlier as the stock boundary. So pick a boundary, and then over here, this is where we define the thickness of our stock. In this example, I have the top of the stock set at Z0 and the bottom of the stock set at minus 375 thousandths. Let's click OK to that. And now OneCNC wants us to select the stock. So we're going to left click our stock geometry and then right hand mouse click to let OneCNC simulate the toolpath. All right, so there's our roughing tool and it's performing the roughing operation. And you can slow down the simulation by the little slider control in the lower left-hand corner. Move the slider to the left will slow things down. Moving the slider to the right will speed things up. You also have your VCR controls down here, so we can click Restart. And by the way, anytime the tool is red, that means it's in rapid mode. So if I move the slider to the right a little bit, it's going to speed things up. While the simulation is taking place, you can rotate, zoom in and zoom out, and of course you can pan as well. All right, very good. There's our very first toolpath. Let's exit out of the toolpath simulation. I'm going to click the little X in the upper right-hand corner, and let's perform our next machining operation. I think we should probably profile this next, so let's head back into the Command Manager inside of our stock toolpaths, and let's profile this using Mill Profile Basic. You'll notice that there's actually two profile machining operations. You have Advanced and Basic. Advanced is used when you're using tools like a bullnose tool or a ball nose tool and your part has a taper to it. But in this example, just the Mill Profile Basic will be just fine. So I'm going to select Mill Profile Basic. Now what you want to do next is you want to take your cursor and you want to select the geometry where you want to start profiling. I want to start profiling right here. So I'm going to left click. And once I do that, I'm presented with these four arrows. These four arrows represent the direction and the side that the tool is going to be placed on. Well, I want a climb cut on the outside, so I'm going to left click this arrow. Now my cursor changes to the word end. That's because OneCNC wants us to select the end of the geometry that we want to profile. So in this case, since we're climb cutting, the end of the profile would be right here. However, there's a shortcut. If you'd like, you can hit the F3 key on the keyboard and that will select the rest of the geometry. I think that looks great, so let's right-hand mouse click to tell OneCNC that we're finished selecting. And just like with our previous machining operation, very first dialog box, this is where we define a tool. Now in our previous example, we created a tool manually. In this example, let's select a tool from the tool library. Now you can do this in two ways. You can select Tool Changer, or you can take your cursor and left click on the tool graphic. The very first tab that shows up is your Recent tab. This shows you a list of recent tools that you've used, and of course you can use any of these if you'd like. However, we want to get inside the library, so we're going to select our Library tab. You're going to notice that all the tools are placed in different categories. For example, bull, nose tool, drills, facing tools, and so on. But we want to use end mill. Over here on the right, this lists all the tools available. For our profile operation, let's use a 1/2 inch high-speed mill. I think that looks good, so we'll click OK to that. And once we do that, you're going to notice that your speeds and feeds automatically get updated. And that's because every time you select a tool from the tool library, OneCNC will automatically calculate the speeds and feeds. Now, you can also overwrite those just by highlighting and typing in whatever you'd like. For example, 3000. You could change the feed rate, let's say 15 inches a minute. That looks good. And you can even change the characteristics of how the tool looks. Maybe we only want the tool to stick out of the holder. How about 1 inch 500 thousandths? And for the flute length, let's make that 1 inch 250 thousandths. Very good. And so for the diameter, we'll leave that at a 1/2 inch. Let's click next on that. And so again, we have our clearances and depths. These work exactly like they did within the roughing operation. Rapid clearance, I have set to 500 thousandths. Plunge clearance set to 50 thousandths. Material top 0. And my final Z depth, that's going to be minus 250 thousandths. Let's click next on that. Now there's two different approach styles. There's ramp, if you'd like to perform a ramp profile operation, or we can use cut levels. Let's use cut levels. So I'm now going to select next. Now the very first option is auto step over. We don't need to use this because this gets used for side roughing. So we can ignore this. For rough depths, I don't want to take it in multiple depths of cut, so I'm going to leave that unchecked. For leave on sides, I'm going to have this set to 0 because this is going to be a finish pass, and we don't need to worry about a wall taper. Let's click next on that. Now, for finish settings, this gives you the ability to create an extra finish pass. In an upcoming video, we'll talk more about this, but for right now, we don't need an extra finish pass. Let's just leave this set to none. We'll click next on this, and this is how we define how the tool approaches and exits the profile operation. You have different styles. I'm going to be using the line arc style for both our lead in and lead out. I'm going to arc into the profile at 45 degrees, and the lead in radius is going to be 200 thousandths. And notice how I have the exit values exactly the same as the entry values. Let's click finish and let OneCNC generate the toolpath. Very good. So there's our profile operation. Here's our arc on. We're climb cutting all the way around the part, and when we're finished, we're arcing off. Very good. Now let's take a look at machining both of these circular pockets. We could use the high-speed pocketing operation, but OneCNC provides a special pocket operation for circles, and that's called clean circle. So let's use this. I'm going to left click to select it, take my cursor, left click the circle, left click this circle, and when we're done, we can right hand mouse click. And just like with all the previous machining operations, the very first dialog box is where we define a tool. Let's define a tool manually here. I'm going to say this is going to be in turret position number 3. And for the spindle speed, I'm going to give this 4,000. That looks good. For the feed rate, I'm going to make this 28 inches a minute. For the tool holder, let's use a 1/2 inch side lock. We'll click OK to that. For the tool type, we're going to leave that set to end mill. For overall length, let's make this 1 inch. And for the flute length, I'm going to make this 750 thousandths. And for the diameter, I'm going to be using a 3/8 diameter end mill for this. So 375 thousandths looks great. We're going to click next on that. Again, just like with the previous machining operations, we have our clearances and depths. These work exactly the same way. So for a rapid Z-plane, I'm going to make that 500 thousandths, plunge clearance 50 thousandths. Remember, this is where the tool starts to feed in. Material top 0. For the final Z depth, well, the part's 250 thousandths thick, so let's make this a little bit deeper because those circular pockets need to be cut all the way through the part. So I think for the final Z depth, I'm going to type in minus 0.300 thousandths. All right, let's click next on that. So for plunge styles, this time I'm going to helical into the pockets. And for the ramp angle, I'm going to use the default 3 degrees. We don't need to worry about the tooltip information because we're using a flat end mill for this. We're going to climb cut. We'll click next on that. Auto step over. This works just like our roughing operation. This is the percentage of the tool diameter. I'm going to have this set to 75%. We're not going to take this in multiple depths of cut, so again, we'll leave this unchecked. Now for leave on sides, let's make this 20 thousandths. That looks good. Now we're going to click next, and in this case, we do want OneCNC to make an extra finish pass to remove this 20 thousandths. In other words, we're going to use the same tool to perform a roughing operation and then immediately perform a profile operation or a finish operation. All right, so what we're going to do is this. Where it says finishing, instead of it saying none, I'm going to have it set to bottom only. That simply means we're going to be performing a finish pass at the final Z depth that we defined a little bit earlier. So bottom only is set. For compensation, we'll talk about this a little later, but just know that you can use cutter comp here. You can output G41 and G42 if you'd like. In this example, I'm not going to output cutter comp, but I am going to overwrite the finish speeds and feeds. The feed rate we used earlier was 28 inches a minute with the speed of 4,000. I'm going to click here, and now I can type in different values for this. In fact, I'm going to up the feed rate to 30 inches a minute, and for the spindle speed, I'm going to kick that up to 6,500. I think that looks good. Let's click Finish and let OneCNC generate the toolpath. So there's our toolpath, and you can see it's roughed out the pockets, and then it's also performed a nice skim pass or finish pass to remove that 20 thousandths. All right, now let's perform the chamfer operation. We're going to head back over to the command manager and select this option called chamfer edge. All we need to do is select the geometry that we'd like to apply the chamfer operation to. So I'm going to left click, and again we have our arrows. I want a climb cut on the inside, so I'm going to left click. Now, the reason that my cursor does not change to the word end is because this is just one shape. So when I selected it, OneCNC understands that's it for that shape. I can't select any more for that shape. However, I could select an additional shape. Let's do that. Let's click here, click the inside arrow to climb cut, and when we're finished, we're going to right-hand mouse click. All right, now this tool is going to be in turret position number 4. RPM, I'll leave that at 3,900. Feed rate, I'm going to leave these alone. This is going to be a chamfer tool. Overall length, that's how far the tool sticks out of the holder, 1.5 inches. Flute length, 1/2 inch. Diameter, 1/2 inch. Now the tip diameter, that's right here. You could type in 0, but realistically it's going to be something like 10 thousandths, 5 thousandths, something along that nature. The taper angle, that's measured from the horizon. So if you think of the horizon passing through the very point of the chamfer tool, this angle between the horizon and the side of the chamfer is what we're looking at, and that's why it's set to 45 degrees. Very good. Let's click next on that. Now for our clearances and depths, I'm probably going to change this to 1/2 inch for that. Plunge clearance 50 thousandths. Let's click next. Now if you remember earlier, I talked about how if you use wireframe geometry, you don't have to create the geometry for the chamfer. And that's exactly true. If we had a solid model, we could use option 2. If we have wireframe geometry, we can use option 1. All right, so over here where it says geometry position, we want to select 1 because we're using wireframe geometry, and we're going to be selecting the perimeter of the shape that we'd like to chamfer, and that happens to be these shapes right here. So 1 is what we want. Length and width help us determine the size of the chamfer. You really only need to type in one of these values. For width, that's going to be 50 thousandths. That looks good. We'll click next on that. And then just like with our profile operation, we have the ability to control how we lead in and how we lead out. I'm going to use the same parameters as before. I'm going to be using the line arc option. I'm going to change this to, let's make that 200 thousandths, 45 degrees. And by the way, if I want my exit values to equal my entry values, just click the little chevron button. That's going to make the exit values equal the entry values. So let's click that. That looks great. We'll click Finished and let OneCNC generate the toolpath. Very good. And there's our chamfer operation. Now, let's take all of our machining operations into the simulator. So let's come back over here to the NC Manager, right-hand mouse click on the toolpath group, and select Simulate Rest. Remember, we're going to be using the option called Pick a Boundary. We'll click OK to that. We're going to left-click our rectangular boundary that represents the stock, and then right-hand mouse click. All right, so here's the very first tool being used. That's our roughing operation. Remember, you can zoom in, zoom out, you can rotate, you can pan if you'd like. Here's our second tool. This is our profile operation. Now we're going to see our circular pocket toolpath. See how we spiral down into the pocket, and then now here's our finish pass. That's where we kick the RPM up. So a helical approach, all the way to depth, perform the roughing in a spiral fashion, leaving the amount for our finish pass, which you see right here. All right, now so here's our chamfer operation. Very good. All right, so we've applied our machining operation for this portion of the toolpath. And remember, the part's being held by a vise. But for now, let's take a look at how to generate a setup sheet. So we're going to exit out of the toolpath simulation. Now to create a setup sheet, we're going to take our cursor and double click on the toolpath group. And from within the NC Processing dialog box, we're going to select Job Sheet. Within OneCNC, a job sheet is a setup sheet. As soon as I click this, OneCNC will create a PDF file. Now within the job sheet, you can see the date, that the program was created, the cycle time, the file name. If we scroll down a little bit more, you're going to see a list of the tools that were used. If we keep scrolling down, we have a nice graphic here that shows us the location or the reference of the X0, Y0, Z0. And notice how each machining operation is divided up into its own separate category here. In fact, we can see that for the roughing operation, it gives us the cycle time, the max tool depth, final Z depth. It gives us the material top. It also gives us the information for the tool station, which tool was used, and so on. Very, very nice. So there's your setup sheet, and of course you can print this out or save it if you'd like using these options over here in the upper left-hand corner. I'm going to exit out of our job sheet, and now let's take a look at generating a CNC program. To do that, you want to select the option called Post. Now I want to take you back here. Let's say we didn't create a setup sheet, and you just want to create a CNC program. The process is the same. You just double click, and from the NC Processing dialog box, instead of selecting your job sheet, you're going to select Post. From here, you're going to give your CNC program a name and also select where you want to save it. In this example, I'm saving the NC program to my desktop. And for the name, I'm just going to use the default name, which is the same name OneCNC uses for the part file. All right, I think that looks good. We'll click Save on that and let OneCNC generate the NC code. You can see now that the NC code's been generated and taken inside the text editor. Within the text editor, you can do lots of powerful things like you can renumber, you can do a search, copy, replace. There's calculators provided if you want to perform calculations. And you also have the ability to upload and download the CNC programs to and from your CNC machines using the included RS-232 software. And of course, you can save, print, and all those options as well. All right, that's it for this video. Thank you so much for watching. I know it was a long one, but I wanted to walk you through all the steps from the very beginning, the whole 9 yards. All right, thanks for watching. I look forward to seeing you in the next video.